Now we want to talk about the idea of multiple scaling. So, this is something, you'll understand the terminology of multiple scaling by the time we get through the discussion. This is a little more advanced topic that comes after your capstone topic, but something you should be able to at least penetrate to some degree with consistent step-by-step effort, following instructions as explicitly as you can. So, let's just start by assuming we've done a frequency versus length model for our pendulum. Frequency we're going to measure in cycles per minute, and we're always going to measure frequency in cycles per minute. Length I'm going to leave unspecified because we're actually going to get our length in two different sets of units. And then we're going to use those two different sets of units with two different labelings of this graph to determine how those units are related. So, now, let's say, and I've got to make a little correction here, we've observed a Y factor of 0.63. Okay, Y factor of 0.63 is going to give us, I think, a power that's approximately negative. Okay, if you do the log of your Y factor over log of 2, you are going to get a negative because the log of 0.63 is negative. Log of 2 is positive. And again, you don't have to understand logs. That's just a formula you can use. So the power then, I'm going to say, is going to be about negative 2/3. Okay, and I'm pretty sure that's right. That 0.63 gives us power pretty close to negative 2/3. Won't guarantee that, but I think that's about it. Okay, so here's our function. Our function for frequency versus length is F equals some number A times L to the negative 2/3. Now this number A is going to depend on what units we use to measure length and what units we use to measure frequency. So if we measure length in feet and frequency in cycles per minute, we're going to get one value of A. If we were to measure length in centimeters and frequency in cycles per second, our value of A would be completely different. Okay? Now, let's say to test our model that we've done with pendulums in the lab, pendulums up to a couple meters long, we want to see if this applies to a pendulum, a much longer pendulum. So we go out to a tower somewhere and we build a 100-yard pendulum. And then we also build a pendulum 1/10 of a mile long. Okay, we find two towers, let's say. One's 100 yards high, one's 1/10 of a mile high. And we measure the frequency. Now, if I went to the trouble of building a good pendulum 100 yards long, I would want to measure the frequency a little more accurately than to just two significant figures. I would measure, maybe count the pendulum for an hour, maybe count it for a day, although I probably wouldn't want to do that manually. And I would get a frequency probably to three significant figures, 3.284 or something like that, and 2.317. So that's what I would actually do. Now there's a limit to how accurately we could do that because you got to take into account there might be a little breeze that might affect the period of the pendulum. There might be other factors that affect it. And of course, the rotation of the Earth will affect the direction in which the pendulum oscillates. So it might be a little confounding there. So we'd probably be limited to three significant figures by that sort of thing. Now that's kind of an aside. That's not really important to solving this problem, but it's important to think about things like that. Okay, so back to the problem. So we get this information for 100-yard pendulum, this information for 1/10 of a mile pendulum. Now, what I'm asking you to do is, using the same scale for F, label the graph according to your first data point. Well, we know how to do that, so I'm going to go ahead and do it for you. I'm going to put 3.2 here so that our data point has to lie here, meaning that 100 yards has to be here. Okay? Now, same scale for your frequency. You have a frequency 2.3 cycles per minute when your length is 1/10 of a mile. So my question is, where's 1/10 of a mile going to be down here? You're going to have to figure out how to use this data to do that. So, label the graph, again, according to the second data point, okay? Now, having labeled it for the first data point, if 100 yards is here, then of course I'd label 200 yards here, 300 yards here, 150 yards, 50 yards, 150 yards, and so forth. But then we're going to do a labeling according to the second data point. So you need to do that. Now, if you can't do that, I'm going to follow up with some hints. So don't worry too much about it right now. Okay, but try to do that yourself. Okay, now, then I say, okay, now you got a dual labeling of this thing. Okay, you got a labeling in terms of your first data point in terms of yards along the length axis, and then, maybe right below that, you put your labeling in terms of miles. Okay? Okay, now, using the dual labeling of your L-axis, I want you to see if you can determine how many yards there are in a mile. Now, if you do that carefully, you're probably going to observe that the dual labeling gives you inconsistent results. I'm not going to say what that means. In the hints that I follow this with, I will. But right now, at least for a day, I want you to think about this. Okay? Somehow your results are going to be inconsistent. And if you look at the graph with good common sense and a good knowledge base, you might well understand why that's the case. Okay, there's going to be an inconsistency. And once you note the inconsistency, you want to think about why it might be so. This is what we do with data. Now, this is a fairly tall order at this level, so you might not be able to do that. Don't think that your future is compromised because you can't, but if you can, it's a real feather in your cap. Okay, so there's the problem. I'll follow up with some hints.